So hey everyone, this is my project demo for my drone interception turret and drone and software. So I originally started off by doing a proof of concept on my YOLO V8 machine learning model where I wanted to prove that I could accurately trace where a drone is in space using my regular webcam camera, and in this video clip you can easily see that it works. So then I moved on to actually building the turret. So the turret is essentially controlled by a Raspberry Pi Pico 2, a NEMA 17 stepper, and a TMC 2209 stepper driver. And that was just for prototyping. I've also designed a custom PCB that controls the stepper motor as well. So now I'll talk about the drone. I originally had it, so I had a little Snaptane SP350 where I was trying to hack into the controller by soldering my own wire inputs, then using a capacitor and resistor to provide voltage that mimics the joystick control. But then I realized that this was super inefficient and it was going to be a really big pain to program and also keep it in place. So I shifted away from that and I instead decided to use a PCB that exactly mimics the shape of the drone PCB inside, so I could when my PCB arrives I can easily just screw it in to the same screw holes of the drone. I'm still going to use the same frame and motor since I've never built or designed my own drone frame before, and considering the time frame I have for this project, I didn't think it was worth me learning and taking the time out of this already extended project to continue working on that and learn that. And this PCB also, to get a little bit more into it, it's using an ESP32 C3 Mini as the main processor, and then I can control the drone over Wi-Fi using the Wi-Fi connection provided by the ESP32, and it also has a BMI 270 inside of it for the accelerometer, gyroscope, and the 6-axis detection. So it's truly an amazing PCB, and I'm really proud of what I've done here. Alright, so now I'll move on to some more of the fun stuff. So in this video clip, I have my turret and my tracking system completely working, and I also coded some OpenCV scripts to graph the position of the drone using where I calculated depth and its exact position using the focal length and the size of the camera lens. And then in addition to that, I did some motion tracking, which is actually working pretty well considering that it was my first time doing this kind of motion tracking and prediction. And that's modeled by that little pink dot or like crosshair. You can see in that previous clip or in the last few seconds of the video, the turret was constantly jerking back and forth to try and home in on the drone. And this entire thing, the stepper was moving on its 5:1 gear ratio and the server was moving on a direct drive, and I think it did a great job of tracking the drone pretty accurately enough for my secondary drone in the future to go and intercept it. So after I made this little drone tracking script and all the turret tracking and pan was working, I realized that my PCBs, I'm not sure when they're going to arrive because of shipping from China, so I decided I may not get my PCBs in time for outpost, but there is one thing I can do. I can start simulating the drone movement and following and tracking and orbiting the drone. So that's what I have in these few clips. I can follow the track drone using the drone that I'm controlling through my ESP32. I've modeled this all in Python on a Jupyter notebook for you guys to see if you want to, and you guys can all run it on your own computers. And yeah, so now hopefully I get into Outpost so I can see all of you guys there. Thank you so much.